so to say. Okay, still with functions. This is partial application, and this is a thing in X where if you don't fulfill all the required arguments, it won't return an arrow, but instead it would return a function which just needs another argument. So let's see if that runs. It doesn't. What should we do? A function returning another function that might return another function, but each return function can take several parameters. Let's have a look at the functions and how they are defined and called. Solve each question, example 0 to example n, by modifying the x with a value of type int. Okay, so we see that this calls this function fu0, this one. And basically this function here, it has some braces for precedence, but parentheses for precedence. And you can see that it takes one argument, but it also returns the same one. So meaning if this function expects the 4, we just pass in the 4 and this should be it. And as we can see, this is correct. Over to the next question. So must return 5, but it uses a different function. So we see this one. This function takes 2 arguments and does something with it. But you can see here that there's always already one of the arguments is given. So meaning now the question remains, is this now x or is this the y? And we can just put in like a huge number here and we can see it evaluates to 11. So if you have the 7 and the 4 and they're added, we don't know the position, but usually the first argument here is computed or is like given from the first position after the function. So meaning that the 7 here is basically written like or appended like this. Okay. So to make this clear, just return the x and this should now be the 4 exactly. Okay, then we undo this one, x plus y, and we have the 4 already given, then we have the 1, and this in summary gives us the 5, which is the expected solution, and this is all right. So up to the next one. Now this uses the fu2 implementation. So the attribute here is bound also to a function, and it uses 2 arguments, and it computes 2 times x plus y. There's no argument already given, as in the previous example. So basically, you can see there's a different set of precedents. And in this case, we must return 7, as it's required here. And 7 can be constructed with 2 times 3 plus 1. So it's like 3 plus 1, and that should be it. So this is correct. Wonderful. Then this function must return a lambda. So we don't know what we should put here, so we just put the 8 here. And let's see if that works. It returns a lambda. We don't know much about this function, but we know it's a function. Okay. Then next question. So here we reuse the example 3, because here we see that there's this keyword rec, which means that attributes in here might depend on other attributes defined inside this attribute set. Okay. So since we already use this function here and we know it's returning a lambda, it means it probably just lacks one more argument. So we put here the 4 and we evaluate. So now we see that x4, this one, returns 20, but we want it to be the 7. So it's pretty much like the example 02. We just have to put in the 3 here and the 1 here, and this is computed then into 7, which is the correct answer. Okay, and the last exercise. Here we basically also have the precedence operator here. We have two arguments. These two arguments are then mapped to n and x. It calls this function and uses the arguments given to the function, but in the mixed order or in a like opposite order. So if we put in the 3 and the 1 here, we end up with 3, I guess. No, it's 5, because it does 2 times 1 plus 3. That's the 5. So what we have to do here is to put it in this order, because then it calls this function. This function takes 2 arguments, multiplies the first one, like the 3, 2 times 3 is 6, plus 1 is 7, meaning the expected return value is 7 here. You can also peek into the solution. If you want to have a preview, if you don't understand something, always just have a peek in the solution and then later redo the exercise until you fully understand it. Okay.